Good morning. My name's Chris Ryan. As you can probably guess, I'm a software engineer and I do C++. Yeah, yeah. This is a C++ anonymous group, but I just use my name, right? Yeah. So I'm going to be talking about binary object serialization, and there's a lot of different serialization techniques out there. But this is just something I did for myself as a learning experiment, just so I know how I can do it. And part is, you guys all know, as software engineers, when you want to make something, when you do something and it looks really simple, you knew you had to put a lot of work in behind it to get it to really work and figure out how it's simple. If it's complicated, you didn't finish your job. So we're going to be talking about what is serialization. Most of these techniques work in C++ 14. One of the tricks I did just for printing requires a 17 feature. I'm also going to show what the modifications are for C++ or for 20 for using concepts. About me, hardware, software, C++, C. Done extremely big scale projects, done a lot of embedded, super small. I prefer Windows, but I'll work pretty much anywhere. And I only prefer Windows because that's what I know, because that's what I've ended up doing most of the time. And actually, let's go back to, I believe in reducing complexity through simplification. If you make something simple, it's not complex. If it's complex, it's not simple. I'm not trying to sell you on the use of this library. Just going to explain some of the techniques in there. I did this as a personal learning experiment to see what I can do and how I can do it. I was aiming to keep this extremely portable. There's nothing platform specific, no backdoor gotcha tricks that some other schemes try and do. I don't work in between the folds and leverage off of bugs. This is just something for you to gain an understanding to put in your toolbox. Most of these slides have code on them. They're overly simplified. It's slideware. I did not intend this to be a wall of code, so I kept it real simple. Most of them are oversimplified, and as the slides progress, I'll add more detail to particular lines that are important. Okay, binary object serialization. The goal is to traverse a data structure, streaming all the bits out and be able to turn around and reload them back in. Going for portable, lightweight, extensible, secure, compact, many other serialization formats. If they use a JSON or an XML, they get text bloat, and those things can become megabytes really quick. And by doing binary and not necessarily compressed, but pseudo-compressed, the footprint can stay very small. If in a hierarchy, the objects point at the same object, I only ever serialize it out once and just keep track of it through some object IDs. Other important fact, no macros. Macros have their place, but I hate it when things are hidden behind macros because it's just inviting things to break later or collide with somebody. Okay, it's not production level code. I said it's slideware. Sometimes I cheated with formatting just so I can fit it on the slide. I omitted most error handling. There is some error handling in my stuff. But this is just because it was learning experience. If just production code, I would have added a lot more error handling and exceptions and whatnot. Mostly thread safe, no guarantees on that though. Mostly C++ compliant. I cheat and I use a couple C-style casts for simplicity. Okay. Yeah, as I said, there's other people that do serialization. They have bloat. My first exposure to binary serialization, and I don't want to hear any hissing, was MFC back in the early 90s. And it believe it or not, it actually did a really good job of it, of serializing things out in binary, including being able to use a crude, simple form of reflection and being able to recreate objects on the fly out of a virtual factory just by having an object ID or object name. And so, as I was saying, this was just an experiment in how can I do this and how does it work? Okay. Pretty familiar with how, hierarchical structures work, and you can easily traverse that and visit everybody and export the data from it. This is a little bit more complicated. So you have to keep track of where you've been, what you've already serialized out, so you don't go recursive or too re-entrant on yourself. And I presume you guys have all seen networks like this or written data structures that do nasty things like that. Fetters, fouling. So what types of data general categories can a class have or that you'd want to serialize out? You have an object, you have a pointer to an object, you have an array of objects, but then there's also references. So we can we can persist all those out, but you cannot turn around and reload a reference because it has to be when it's initially constructed. I create an empty object and then set the values in it. And also, you can serialize stuff out, but if it's const, you're not going to be able to read it back in. So I just leave that as a dangling modifier of non-const data, non-reference. And other things like strings, vectors, arrays, lists, shared pointers, other intrinsic types, those are all objects. Even if it's shared pointer, it acts like a pointer, it's an object. So you can treat it like another object. Yes?
You don't do any special cases for those? Like a string, you don't do a special case for it, you just serialize it as is?
Now, the question was, do I do any special handling for things like strings? You're talking C strings?
C string or stood string?
Or stood string, I actually have a specialization for that. And it goes out and it gets the character bytes and it writes out the length and what the array was in it. The C string, I do the same thing. And by C string, I'm talking about an actual array, so I know the length. I don't go out and do a strlen on it. This is a simplification. Well, actually not that simplification. This almost basically runs. I have a file source where I get my data from. I give it to the archive object, and I just stream my class into it. To turn around and load it, I open the file, I create an archive and I load and I stream into it. And each class most classes have a serialized function. I just ask the archive, is it storing? And I just stream each data member out. Is it loading? I stream it back in. Pretty straightforward. I think many of you guys have seen something along those lines. The way that each of those operators work, where it had the archive object you're streaming into it, and then I can grab hold of any object out there, is I just grab it as a reference. And then I tell the archive to save that object. And it goes through and figures out what type of object it is. And so that's it, all done. It figures out, it knows how to do all that. So, now, you have to take care and handle each of the different types of objects. Objects ref, a reference to a pointer of that type of object, and then arrays. And it deduces the type and the size of it. But using SFINAE, I have to basically figure out what special handling am I going to have to do for each type of general category of object. Integers, plain old data, and if it's a serializable, which we'll get more into that of what I actually have as my dynamic serializable object, or if it has a serialized function in it. And I'll show you some of the difference of that here soon. And this is actually how I detect, and this is a trick probably many of you have seen. Stop that. Winner. If a class has a serialized function, this basically comes back as a yes. and the size of a yes is 1 and no is 2. It detects that, and so the value of this static class is either true or false. And so then I can just say, does this have a serialized type or a serialized member, that even if I don't know what that type of class is, I can safely call serialize on it. So I have all these const expr rules of is integer, is plain type, has serialized, and then actually, did I skip a slide? Yeah. Normally, you'd have to say enable if it's an integral type, enable if it's a plain. This kind of gets real wordy quickly in a class, and to make that look a little bit leaner, I can declare some usings, and I say if integral type, and that uses the enable if. And so in my classes, or in each member, I can just say if integral type without having to have a whole bunch of extra noise in my class. And this is a blown up, a little bit more focusing on these particular types. And these are the save and load for each of the different types. If it's an integral type of plain data, has serial or serializable. Just zooming in a little bit on detail. And in general, slideware, to save integral types, a paranoia thing I do is, because I don't know who's going to be loading this, so I adjust the byte order for integral types. And so I change the byte order to effectively a network byte order. So if anybody turns around and goes loads it later, they would deconvert it from network byte to their host. I can just save that out. I convert it and save it out. If I load it, I create one of these types. I read into that and then convert the byte order and save it back into my data. Plain data, trivialable, copyable. Just do a blob read write on that. If it has a serialized function, I just call that object and say serialize yourself. And the archive knows whether it's loading or saving, so whether it's load or save, it's still calling the same thing, and the object is internally itself decides. That's if it has serialized. If it's serializable, again, I'll get to a little bit more of the magic, what the difference is on that. I just call the object to tell it to serialize itself. Yes, Ben.
Are all of those overloads mutually exclusive for a given object?
Yes. Oh, yeah, Michael.
Has serialize and serializable looks like they're both calling the same function.
They are. Oh, he was asking if has serialize and serializable is calling the same function. And I'll show you the difference of what those two different ones are doing. But basically, a class has a serialize function, and I can just call it. In this case, it through the deduction that I had done before, it knows it has a serialized function. This one is based off of a base type that's a base serialize, and it detected that, so it knows that it can call serialize on that. These look like they're doing the same thing. They effectively are. If serializable can handle polymorphic types, where the other one cannot. And this is the crude generic specialization of how I handle arrays. Basically, I just save out the count, and I iterate through each item in the array and send it to the archive. And depending on what type that is, it goes re-entrant back into the streaming operator. It figures out, is it an integral type? Is it a plain data, serializable, or has serialized? And it or one of the other specializations for maps and lists and vectors, whatnot. And each element knows how to do that. It's all because it's multi-levels of reentrancy, parsing this thing apart. When I go to load it back in, I get what the count was I saved out. As a safety factor, I verify that I'm reading back into an array that's the same size of that I had serialized out data that I know I'm expecting. Same way in terms of size mismatch, that's an error, and it's going to be overwriting garbage all over the place. Okay, so this is what we saw already. Basically, we just serialize out my class or serialize it in. This one becomes a little bit more complicated. Normally, when you give a stream a pointer, it just takes the value of that pointer and spits that out. When you do that to cout, you just get a number there. This one knows that it's going to be treating this object as if it's a pointer to an object that I can serialize out. And I think I progressed there. So here it's not inheriting from anything, and I can just say is save. And I think on my slide where I've changed terminology a little bit, it's either, sometimes I said is storing, but it's really just meaning is save. I just save out the particular data or stream it back in. However, if you're dealing with a base class, I go out and get the data of a base class, and I try to go out and just archive out my base. It would do some slicing, and it would only call the serialize for the base, and this one didn't have any members. It wouldn't save anything. If it did have members, you'd have your normal if storing or is save and go out and save its members. But it would forget all about all the derived types. First, this is not virtual. If it was virtual, it would go ahead and save these. But over here, I have a null pointer, and I stream the data back into a null pointer. First of all, I have to have a place to store it. If it's this type of class, it's just a solid one-off class, I can actually know, based on the type of this object, I can just go ahead and I'll new my class, because my deduction can figure that out. And then I can call the serialize to stream into that. On this type, the multi-level derived, when I go to stream back into my base, it would create a my base object and then attempt to stream back into it. And depending on whether this is virtual or not, it would either just stream in the base class. If it was virtual, it would go out to the most derived and then start trying to serialize that into reading the stream into the data for this class. Gotcha though. I didn't know a derived type, but the stream might have the derived in it. So I had to come up with this is the difference between has serialize, it has a serialized member, and serializable. And to do that, I do some CRTP, I don't want to say tricks, but mechanism. And the serializable class has a virtual serialize in it. It also keeps some type information about what this type of object is. When I go save out my base, it calls through the serializable mechanisms, gets the most derived data type, and it stores out what type it had stored out. And I'll give you some more details on exactly how it knows which type is that. Then when it calls to load it in, it's a my base, but it looks in the stream and says, oh, you saved out one of these types, which is based off of a my base type, and it constructs a default constructible, one of these objects, and then serializes into it. A little gimmicky trick that I use for multi-layer type stuff, and I actually have a typo on this. When I call because virtual calls it furthest derived serialize, the first thing I do is you drill down and you serialize in the base members. So most of my classes, I put a using base, and this actually should say, not my base, it should just say serializable. Because between this class and this class, there's actually a layer of a CRTP class, or a template. It's called serializable. So when we drill down, I call base serialize, it would actually be calling into the serializable for scope for finding the serialize function, and then which ends up drilling down and saving out the data of the base. It returns up and then saves out the data of the derived type. Question? Yeah.
Is that distinction material to this code working correctly? Like, does the serializable have state that would get serialized?
No, it doesn't. But if someone were to come along and change my hierarchy and insert themselves their own middle class in this, this would accidentally skip it. That's why I always just scope it directly to the immediate base. And in theory, in good design, you know who you inherited from. You don't necessarily know who they inherited from. So you don't want to skip ladders in the rung. Yeah. So, and just by saying serializable here, I don't have to give it all of the other types. It automatically knows that we're in this, and then that was my base, and that's what a serializable is. And it does all the decorations internally itself. So pseudocode for saving out a serializable object is it gets the object ID from the furthest derived object, it saves that to the stream. If it's the very first time that object ID has been stored out, basically I grab the address of that object and I store that into a map, and it gives me an object ID. I store that object ID in the stream. There's also some other information of the hash of that object. So when I go to stream it back in, I can look up that hash and recreate that object. For loading, I get the object ID from the stream. If it's the first time it's loaded, I go get the object ID and the hash. I dynamically create the object. Magic mechanism to be shown later. And then I add that pointer to my object map. So if I ever come across this object ID again, the only thing that had to be out in the stream was the object ID. And then I can do some fix-up. If it did exist before, I just get the object pointer out of the object ID and assign that back to the pointer. So I didn't have to recreate it. I just did it. It's a little glorified linking fix-up. So we basically talked about this already. If I have my class and I derive the CRTP for that from Serializable, and of course, Ben.
You've been talking about these serialized functions and saying they're virtual. The CRTP I'm familiar with usually is introduced to avoid virtual functions at runtime.
I'm using this.
Are you saying the static virtual, like CRTP style virtual, not actually runtime virtual?
No, I have runtime virtual in it for the serialize, and that enforces anybody who inherits from the CRTP class has a virtual serialize function without having to say override in the class. And in the serializable, because of the CRTP, I pass in the type, and I'm going to show you the guts of that here in a minute. But then it knows I have a create function in there that will instantiate one of those types. And that's how I can recreate it and add more to that mechanism here shortly. If I'm not using the virtual reconstruction mechanism, I don't have to do the serializable in the CRTP. It's just a class that just has a serialized function that knows how to reload its data. Okay, so here's a little bit of the way the class hierarchy for the magic of the serializable stuff goes. This is a little bit small because it's going to fill up the screen. I have a my class with a serializable function. It knows how to save its data. But because it's going to need to be extensible through the dynamic system, it derives from a serializable CRTP template, giving it my name of the class. And from this I have my serializable, and it uses a base, and the base that it happens to use is a serializable base, which has the virtual serialize function in it. I need to have a base class that is non-templatized, so I can actually just use a base pointer of serializable base. This class you cannot just reference as serializable because it has all these declarations of that it's really of this class type with this type base. And you can't have a base pointer for every single one of these. So I have a generic serializable base that has my virtual serialize function in it. There's more not magic, but stuff that goes in here. This is all simplified. Yes, Phil.
So I noticed you use the same name, initial cap serialize for both the virtual method in serialize base and the not virtual method in my class. Oh, wait,
virtualization is automatically inherited. Yeah, I could have decorated this and put this as virtual.
That means,
and I could have also specified override.
Okay,
yeah.
So you're doing the serializable base with that virtual declaration just to make that name virtual all the way down the hierarchy.
Correct.
Okay.
Yeah, and so the question was, why do I have the base is virtual and the derived's not? The derived will automatically inherit the virtual mechanism, and so
if you put override in there, make it clearer.
It potentially would, yeah.
It would.
But it changes.
Yeah, well, this slideware, this is just going for minimal impact, yeah. So, and for the video, the question was, can you remind me exactly what the question was?
Shouldn't you have override
Oh.
to show that it's a virtual function somewhere?
Yeah, shouldn't I use override on there? And I probably should. But this is just the user for this class. And if they had, if it was all the way back at the beginning, on the first slide I showed you where we did not have this base, and it was just a class with just a serialized function, this is extending that so it automatically gets that, and the user doesn't have to necessarily understand that they are using a virtual mechanism. Thank you. Okay, back. I think I skipped a couple of points here. So to create one of these objects dynamically on the fly, I have a pointer to function that will give me back a serializable base, my furthest based object, and I store a hash and the pointer of the function for the create, and that mechanism is all done inside of the serializable template in here. And to store this data away in this type info, I get the name, I hash it. You could use whatever mechanism you wanted to keep it unique. So the hash is always unique for this particular type of object. And I store the pointer to the function for the create. In this type info, I have a static map inside a static function. So when this thing is created, this type info, which will be in a static object, I just say, get me the map, index the hash, and store this. So if I have the hash, I can ask the map later, of get me the type info for the object that has this hash. That hash ID is what's stored out in the stream. So when I read it back in, I can look it up. In the CRTP template, this is the create function of the type, which is actually the derived type. And this is what I really needed the CRTP mechanism for. And I also have one of these type info static for this particular type. So when this is created pre-main, it goes to store this information away. It creates a type info of a serialized type base. That means basically it's the static inside of this guy, so this line. And for there, I get the type ID of the name and the pointer to the function of the create. This is in scope of this class when I create this, so I can directly just access and store away to this pointer to this new of this type. Any questions on this? This is kind of a little bit of the core of the mechanism of how it stores that away. So when this object is created and it passes in the name and the create, that's when it adds itself to the map and to the hash and stores its this and the type info. Michael.
Where's create coming from?
Create, wrong pointer. It's right there. And this is the create function that will go out and new me a type of this type of my class, because that's what I had passed in was my class. So my class goes to there, and I knew it of that type. Originally, this session was not going to be presented here, but someone had dropped out, and I went to go fill in. I originally was not going to present it here because Phil and Daisy had a presentation on Wednesday where they had their own mechanism, and we were comparing notes in the bar. And theirs is doing something very similar to this with the static map inside of static function. And that's how they can get at their type info and go back and recreate the object on the fly. So when I want to find one of these objects, I just ask a type info, so static says find hash. It grabs the static map and it looks up the hash and it returns me this type info. And at that point I can compare the hash to make sure that it's what I was expecting. There's a couple other internal things I can compare to the object to make sure that it's the object that I'm expecting, or a object of a derived type of this type, because there's multiple layers of the serializable in a derived class. And from that type info, then I can just, from the type info, it knows the class that it came from, and, it gets to create, and then it can create one of those for me on the fly. Okay, so to string it all together now, my class inherits from serializable. When the serializable CRTP base is created, it has a static function that gets the type info. It creates a static type info, fills it with the information of the type ID in the create, which is one of these, which the constructor gets the map, and fills in this information on that. So it's bouncing up and down quite a bit there. If we have multiple layers of inheritance, and I don't think I have a slide for this, but if I have my derived, and I do a public serializable my derived, comma, its base class, which would be potentially my class, there would be another layer of the CRTP between my class and my derived, which would also have the create function for the my derived. Yes?
Question on deriving from the my class. So if I have a my derived class, is it going to inherit from just my class, or it also has to inherit from serializable?
It itself, and I don't think I have a slide for this, but yes, it does. There's multiple layers of my derived. use a CRTP derives from the CRTP template, serializable. That
Would that be multiple inheritance if I have?
no, it's stacked inheritance. It's not.
My class is going to derive, my derived class is going to derive from my class. So that's one level. And you're saying it
No,
also
your
has to derive
class
from-
is going to just derive from serializable passing the base template argument.
Okay, so the question.
Serializable is a public base.
So the question or the point of confusion was if this is going to be actually a multiple inheritance and it's just additional ladders. If you were in our previous slide where we had a my base and my derived, they're stacked on top of it. What this does is it injects a serializable between those two, so it has all the information to create the my derived, but underneath the my class, it also has a serializable where it has all the information to create my base if you're only going to be creating.
That's fine, but are these classes purely for serialization or they can be real working classes? So I have a method-
The my class and the my derived, those are application classes. The only thing that's a modification.
Well, hold on,
Yeah.
stop you there, because if I have my derived class, I want to call a method in my class, right? I have to directly publicly inherit from it,
Yes.
right? And then if I also want that derived class to be serializable, I have to also, it seems, derive from serializable my derived class.
Correct.
That's multiple inheritance.
Draw the picture on the board.
Yeah.
There's stuff up there.
Yeah. Okay. You have class my base. Class my derived that inherits public from my base, and it does its things. There's a serializing function in here. You wouldn't be able to read it anyway, but I spelled it wrong. Serialize. You can have any of your own functions, any of your own data you want in your base. This one also has a serialize. And then and it states out whatever data you have in your class. You also have your own methods in this class. What I do is by changing, injecting serializable, inheriting from my base.
Wait, you need my derived in there too.
Pardon. Right, CRTP part of my derived, comma, my base, injects and I'm going to show it as a class even though it's really a template. Of serializable and as written as a class, it would be I just cannot write public my base. And this would have the create function and the static type ID or the type info. So if you were to have say you had a virtual function here that you would call, these are stacked and then they inherit. So if you called it here, it's actually going to go to the most derived and call that virtual implementation here. Underneath my base, this also inherits from Serializable.
You answered my question now, so-
Okay, I just want to finish this out of my base, which would then have class serializable base, which has the a virtual serialized function in it. And there's the class serializable able that has its create and type info information. So it'd be create and the type info in there, if that's readable at all or makes any sense. So these are one derived from the next, derived from the next, derived from the next. So okay, now what do I do with my clicker? There it is. So we kind of covered this a little bit already, but to walk through it again. When it pulls the hash out of the stream and says, I need to create one of these guys, it asks type info, find me the hash, or give me the type info from the hash. It grabs the static map, it looks it up, returns the type info object, which has the hash in it again, just to verify that it's the right one, and the pointer function create. Pointer function create calls the create function, and it creates a type of a new of this type. Default constructible, that's one gotcha on this, which then creates one of these classes. I get back a pointer to the serializable base, and then polymorphically I can call serialize on that, giving it the archive, and it calls the furthest derived serialize and goes and streams its data in. And Phil, your mechanism has a lot of similarities to this, correct?
Generally, yeah.
Yeah. Phil uses a dynamic registration where they get an object ID back of a sequential number.
Dynamic initialization.
Yeah.
The user doesn't have to write the registration.
Right, and neither.
You don't either.
Yeah, because it derives from serializable with the CRTP. That's all the magic's happened. It's all initialized before main. One of the big differences, I use the type ID and get the name from that. And just a note on that, that is not universal. And you're not guaranteed that it's going to stay the same forever. Different compilers have different names and how they store them away. So this will be portable within that same compiler, typically across multiple versions, but you're not guaranteed that the next version isn't going to change. And actually, according to the spec, you're only guaranteed that the name is unique within that instance of running. But, okay, I cheat, and I know that it's probably going to stay the same across the compiler for that version. And a benefit of what I've done here, and by using a constant name, and I use that as a hash, the hash is going to be universal. I can include this class hierarchy in multiple different executables. And I could have one executable stream out its data and another one stream in that data and reconstruct these things. And because it doesn't depend on order of registration, it's all based off the hash ID, it can reconstruct these data structures in an entirely different application if it knows about the same class and then the type ID name was the same. Ben.
So I think the important point here about the same, so you're hashing the contents of the name. You're not using type ID hash.
Correct.
Because I think in most implementations that just returns effectively the pointer in memory, and that would definitely change between runs.
Yeah, and that is something which even has a bigger asterisk on it of guaranteed not to be stable or unique. By hashing the string of the name, you get a little bit more comfort in that it's going to be longer term constant, and normally within a vendor, potentially across even multiple versions or revs of the compiler. Okay, so this is my typical style of doing this. I inherit from the CRTP class Serializable. I like putting a base pointer in there. Many people have argued for years about why does we have this pointer, why don't we have a base, either pointer or a base type. There's many reasons why they decided not to do that. I know I'm only doing single inheritance, so I do it. And it keeps it safe, so I know I'm not going to break something. So when my serialize gets called, no matter what was above me in the hierarchy, I drill down into the serialize. If it's just into the serialize and the serializable base, it's an empty, there's no data, it's a no-op. Then I either do save or load. Feder.
Well, two things. First of all, I don't think that actually compiles. I think you have to say serializable of serializable of my class.
No. It knows that is an alias because it automatically fills that all in for you.
Okay.
Filled.
Do you have to write both versions? Can't you just generate them from a template? The read and the write.
And actually, I'm going to get to that. This is the longhand version of spitting it out, both of them. I actually have an operator that will do both, and it calls the serialize, and internally it figures out, is it loading or is it saving? And it makes it less error prone. Because the gotcha on serialization, you have to read things in the same order that you wrote them out. Something that's not addressed in any of the slides, occasionally you have a member which you cannot either serialize out, or it has a particular complex state to set it up to populate it. Maybe it generates some big lookup table or connection to a database or something like that. When you go to stream out, you can interrogate that object to say, what database are you connecting to, what password are you using, that type of stuff, stream it out. So when you go to stream it back in, you would stream those into local variables and then call methods on your member object to do its proper initialization. But you still have to write out and read in things in the exact same order.
Yeah, but that would be half-coded.
Yes. And that's just for some very corner cases. Most of the time you don't need to do that. So here's the multi-layer serializable, which is kind of what I was doing there. But then here you have a serializable instant, and above here you have the serializable. But the middle one is serializable my derived, and the one above is serializable my base. And I could have made this two separate serializable templates where I knew if it was going to be in the middle between two classes or if it was going to be up at the top. I found it easier to just have a default parameter of serializable base for what the my base was if they don't supply it. If they do supply it, it doesn't use the serializable base, and it depends on who they're inheriting from to eventually have inherited from serialized base. Okay, we talked about you can have a file, and it handles all of anything the archive needs to do, reading and writing. And same for when you're loading, it handles reading and writing. And it's implemented basically, just as I said, it has a load and save, and then you just virtually call off of that and get load or save, and then you save your particular blob of data that the archive mechanism is saving. I can also do have an archive stream something out to a socket. So I have a socket source, and I could construct a client or a server, and they can connect to each other. I stream out on one, the other guy goes to receive it and can just archive, just serialize in the data across the wire. And it actually, and I think I have some examples of this later, you can write from the server to the client. The client can process some information, turn around, change the direction of the stream, and respond directly across. And the servers can then stream that response in objects. And here's an actual example of that. So I have a socket. I have my class. I send that out to the archive. I have an empty response object, and I wait for the response. On the received side, he's waiting for my class data to come across. He takes the response, calculates the response based off of the my class data, and sends that response back, and it receives it by streaming it into the response structure and passes it off to somebody for handling. Has anyone seen wrinkled foreheads on that, or is that you taking my word for it? No objection? Do you want me to stay on that a little bit longer? Okay. And optimization I do, because I save a lot of object IDs out, which are both the instance and a type of an object for the very first time it's been saved. And so I'm going to hit a lot of these ID numbers. And I could have just said, I'll always just stream those out as a 32-bit int or uint. But assumedly, initially, I'm going to have a lot of really low IDs because this is an incrementing ID in my stream that goes back through the different object maps and ID maps. So I didn't want to waste a whole lot of space in there, so I store it in a base 128. And if it's between 0 and 128, it's just 1 byte, and it has a stop bit on it. And I would turn that on to say, that's the end of my result. If it's bigger than that, up to 16K, it would take 2 bytes, and then 3 and 4, until it hits the stop bit at the end. So initially, a lot of my IDs and types are going to be potentially re-referenced or reused, and it's only going to take 1 byte to store them. Keep the file size small without a little bit extra bloat in there. But it allows for growth up to 268 million IDs. I've never tested streaming anything out that had that many classes or that many types or that many instances of these. You're going to quickly run out of memory if you have that many objects anyway. But this is just a...
Are they typically ordered?
Because it strips off the bottom 128.
No, I mean, are they, because if they're ordered in a stream, you could write the deltas after the first one. Then if they're ordered, they would all be small.
Oh, he was asking if the IDs that are out there are
Because if you basically
always ordered.
if you tend to write things like 0, 1, 2, 3, 4, 5, blah, 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 1 million, you instead set the differences will
Right.
be 1.
And so he was asking if I can just store the delta between what the IDs were. Some of these IDs are, when I go to stream out a pointer, the very first time I give it an ID, and I stream out that ID and the information about how to recreate that object. The next time I reference that exact same address, I looked it up in my object map, I see what the ID was and say, oh, I've seen this before. I just stream out the ID. So it could happen randomly anywhere throughout the stream. I'm going to run across these reused pointers of where all these multiple different structures are pointing and sharing data. So they're not going to be consecutive always. I initialize them as starting at small. And I actually have one of these that values that I pre-reserve for a null pointer. If I go to someone has a null pointer, I go stream it out saying this object was streaming and used a null pointer. So that way anybody else that points to it's also going to realize that it's a null pointer, without me actually having to create an object and serialize out a completely dummy empty object. I just say the ID for that one is ID null. Just a gimmicky, not necessarily gimmicky, but a shortcut way of storing those out. Okay. These are all the combination and permutation of things we handled. All the integral, the plain old data, has serializable, and I can do load and save on objects of those types, pointers of those types, which are really pointing at those objects, null or not, an array of those of a type of object. And so not only do I have knowing how the specializations for the integral, the plain, that has serialized and serializable, I have the further specialization for shared pointer, unique pointer, vectors, lists, arrays, maps, strings, char strings, or a blob. If there's no way that you can ever figure out how you actually want to save your data, or you actually have a class that just has a blob data that it's carrying around, of course everybody knows blob, binary large object, you can just write it out if you know it's totally trivially relocatable.
You just have to know that it's address free.
Pardon?
You have to know that it's address free, that it doesn't have any pointers.
Right, and that's up to the stupidity of the user. And so,
Have you wrote all these load save methods for the standard library? Or you someone else to write them?
of these I have, and it covers 90% of the collections that are out there. If there's other collections that could be added and sensed into the archive. These are all methods inside my archive class. Okay, so say you have a map between a string and a vector of shared pointers. The argument type deduction would go through and figure out top level, this is a template, or the template would realize that this is a map between a key and a value. Each key is a string. Each value is a vector. Oh, I think I forgot to say that when I was reading that before. It's a vector of shared pointers. It's a vector. The string you can save, I have a function for that. The value, when it goes to save that out, it's going to save as a vector, where the type gets deduced that it's a shared pointer to my base. I could go save the pointer, a shared pointer of my base. And if it's serializable, if it's a serializable type, it calls to save on that type object, and so then it calls to serialize inside that type object. I go back to that. This is just multi-layer induction and deduction. Yes.
So obvious immediate question. The whole point of having shared pointers is that lots of them point to the same place.
Correct.
How are you going to figure that out when you deserialize?
When I serialize out, I store in a map an object ID of where that pointer came from. If when I go to serialize out something again, I look into my map, my object map, and say, did I ever serialize that out? And I only just save the ID out.
But it's I mean, the shared pointer is a different. The next shared pointer would be a different object. It just points to the same target, right?
But they're of the same type. They're of yeah.
Oh, but the two shared pointers of the same type point to the same or two different things. Okay, you have a specialization for a shared pointer.
Yeah.
That of course serializes the bits and then serializes the target. And on the target is where your ID will kick in.
Yeah, right, the ID is there. So when I go to stream it back in, the first time it hits that ID, inside of shared pointer, it says, oh, this is just a pointer. I'm really just saving a pointer type. And it goes, looks up that ID, says, I have not saved this, or actually when you're saving it, says, I have not saved this, it saves the object. If you stumble across that again, it looks in the maps and says, yes, I've seen this before. I'm just going to give it the object ID it had, 27, and just put that in the stream. I don't save the object again. When you go to stream it back in, the very first time, it knows how to recreate that object. It stores that pointer in a map, the new pointer in the new instance in the map to that ID. Later in the stream, you run across ID 27. You go look in the map. I already know what that is. I don't have to restream that in. I just give it the same pointer I had before. Question.
So what you're saying is that if you have shared pointer then and it's part of the same archive, then when you save and when you load, there would be a single shared state still.
Yes, it reconstructs the previous relationship.
Single serialization event. If you have two different serialization events for something that have shared pointers, when you deserialize, you cannot guarantee that they will have the same.
Each serialization or each archive has its own copy of the map. When you close out the map, or in that example of where I change directions on the socket, that flushes the map. That creates a new instance of the map.
But doesn't that imply that the archive has some kind of table somewhere? It's random access, things like that. With requirements from the archive.
The question is, does that imply that I'm keeping I can't remember the exact
You
word.
showed this in earlier slides.
Yeah, this was on an earlier slide before you came, but so we'll talk about that later. Okay, we've seen this before, and this is the okay. Actually, this is a generic class that is not derived from the CRTU mechanism that has serialize. My deduction types for the if enable realizes this class has a serializable, I can call that. If I have a pointer, now this also does not have the dynamic recreation mechanisms. If I have a pointer to my derived, it can create then my derived. If it knows it's talking to one of those types, call it serialize, it drills down and calls the base serialize. And this is just for a single level, multiple datas, multiple streams out. Shortcuts on this, rather than doing the if is save and then in the else case, I can, and I know that this is a serializable object, I can just say, or even if it's not, I can just say the archive, serialize my data A, serialize my data B. It goes through all the reentrant deduction types and will save that out. It knows whether it's loading or saving. I don't have to worry about getting the data types in the wrong order. They're fixed in order there. Yet another shortcut for that is a double ampersand. And I believe this is actually the same shortcut that the boost serialize uses for their operator. Do they use single? You have to be careful when choosing which operators you want to use. The streaming operator has a relatively high precedence. If you choose an operator, I thought it would be cute to do streaming equals, because it looks like an arrow and which way the data is going. That is much, much lower. And depending on what you're streaming out, or if you're going to be chaining your streaming, the order of the streaming just gets totally hosed in the type of objects. Is that what you're going to point out?
Yeah, the precedence rules are.
Right. So you want to go with the things with the best precedent, so you don't change your order. And if I wanted to, I'm not sure if I'd say this in an example down below, I could just say arc and my data and my data B. Phil.
Retain short-circuit rules for custom overloads?
If you use them in the wrong order, things can get hosed, and they'll try and.
And that has a short-circuiting rule. The first time it kicks in through, it stops it.
Not for overloads. I think that's only for Boolean types. that it does the overloading or does the short circuiting. Isn't you guys have to keep me honest on that or not? Phil?
Yeah, just the other detail on the precedence thing, it also needs to be, I think it's left associative.
Yeah. Right, and that way on the streaming also, if I wanted to for streaming out, I can say archive stream my data A, stream my data B, and put them all on one line for outs and then all on one lines for ins. Whoop. Most of the time I actually end up using the and just because it's simpler and I can make it shorter and I'm not going to break anything. They're always going to stay in the same order. Now, everything I had been doing or showing you is basically 14 and 17. And these are all my context per rules and my usings for the if enable. And part of my promise was I would tell you how to make this into a C++20. You convert all the other rules to concept, integral type, plain data, it has serializable and serializable type, and rather than the long, or somewhat longer, complicated if serializable, it just becomes a concept, and you say save serializable type auto, and save serializable type auto pointer reference object. And this is using abbreviated concepts, template functions or function templates, such that it becomes very readable. One thing I need your guys' help with, and I think this is just a failure in abbreviated concepts functions, I have all my functions that handle arrays, which have types and sizes. I still have to have the template for the count of how long an array is. Does anybody know how to do this for an abbreviated type with concepts? So you can say serializable auto array, that's a type, and the count without having to do a template size? Or is that beyond the limitation of abbreviated concepts?
You have to write a concept, I think, that says it's an array, and then it would have a context for size that you can call the same function.
So then I would be able to say serializable type array count.
Well, these are C arrays, so no, they decay, so I think you start with this.
Okay, I was hoping that I would just be able to say serializable type auto array bracket auto count close bracket. Yeah, I was hoping that the abbreviated concepts had that type of idea in it. So, and as has been quoted in many times, and I should have put this in the intro, I'm not an expert, I'm just a guy. I don't know it all, and matter of fact, I was up late last night trying to get the concepts working correctly because I got requested to do this talk with just a few days' notice. I was going to be giving this summer in Toronto, and we had someone drop out because they got sick, and so I volunteered to fill in, and so I revved quickly what I had there, and then with my C++20 and concepts, stuff I'd had started breaking, and I repaired it last night at about 1 a.m. And I didn't want to post it on here if I knew that it was going to be incorrect.
The concept is applying to the array element there,
Correct.
not
The count is a separate.
if you want the count to be part of the thing that's passed, I don't think you can do that with C arrays, because they're all going to decay pointers.
Right. And so the point was, and what Ben was saying, of the serializable type is only of the array type, not the count. And the count would decay to a C. The element type. Okay. Right. That's what I was intending to say. And then the count is a C array style.
Right.
So which is an entirely separate beast.
Yeah.
Yeah.
You can do it for a stood array. You could write a concept which included the fact that it's a stood array and it has a serializable element. And then you could get the size out.
Yes. But then that, But I actually have another mechanism of that for the stood arrays of just enumerating through all the elements in there and serializing them each out after I have the count. Phil?
Would it work to always handle arrays just in terms of a span and accept an overload that deals with an R value span, so you can just say serialize span of my point, array pointer count at the call site? Or does span have a constructor from static sized arrays?
I don't know. I don't have enough experience in that.
For the room, I guess.
Yeah, there I'm just a guy. The question was, unknown point, if we could just use a span and it would be able to deduce from an array what the actual length was. And that's an open unknown question apparently.
Or you can use you can do a template, right, where you let the compiler figure out the size.
Yeah, and that's exactly what this is doing right here, of figuring out the size. In the 1417 version, you'd had to say template type, which would be in the type of the array, comma, size t count, which is the template. And so this is the abbreviated format. Yes?
Because if you have two-dimensional arrays, two-dimensional C arrays, maybe it will not recognize this.
Well, two-dimensional C arrays would, I think you could deduce it as nested array types, that it would be an array of one type, of an arrays, and then it would drill down, and I would have to test this, but then it would be that it's an array of those inner elements. Marshall's giving me a funny look on that. Ben?
I'm giving you a funny look because every time people try to deal with two-dimensional C arrays or multi-dimensional C arrays, they charge into it and then eventually they just kind of back away and say,
Yeah.
maybe not.
Marshall's point was anytime that, and normally this is novices, and I've fallen myself in this loop, of when you try and fake a multi-dimensional array and you want to reference just a row, you end up having to return a reference type of that row that then you can dereference for the column type. It can be done, it's pretty ugly. Phil?
So I just looked up span's constructor, and it does have a constructor from static dimension C arrays. So you could, if you overloaded for R value span, you could just say span of that, and in the serialized methods, and it would work.
And it's
Okay.
a constructor.
Well, so Phil was saying that span can deduce from an actual array. And I'll have to look into that. I'm not sure if that's what I want to do or not, because it adds just an extra layer of complication, and I want things to maintain and look simple. Okay, got some examples for you. Rather than actually running them real time, I ran them and grabbed screenshots. Honest, these work, on my pledges in the union member of the software engineers, right?
Software engineers field.
Yeah. So I have a class, and this will be similar read-write used for several different examples here. I generate a tree. It's of nodes, and it's a typical tree with left and right pointers. I have a little utility called draw tree that draws a text version of the tree, and so you can see the hierarchy, and it will display the nodes and ask the nodes to print themselves and their values. So I print the tree, I open a file archive, or a file, I pass it to the archive, and I archive it out. Close the curlies on it, and something I want to make sure that I say, file has auto close, the archive has auto destruct at the end of the scope. I go to turn around and I'll reload it back in from my node archive, read it through the archive, and these are actually using shared pointers, even though there's actually for the root node only one instance pointing at it, but I like shared pointers everywhere. I typically don't use unique pointers. Why use a unique pointer when you can use a shared pointer?
Because it's cheaper.
Yeah, and you don't have to think as much.
Were you soliciting for the list, or
Yeah. Personal bias ignorance. I'll just leave it at that. So then it streams back in, and the null pointer, of course, or the PN is a null shared pointer, and I stream into it. It reconstructs the whole thing. This is what my node class looks like. It's got a data, it's got a left, and it's got a right. Whoops, back. And when I go to serialize it out, I just say archive data, left, right. It knows how to deduce the types. This is my little text tree of, this was a tree before I wrote it out. The archive entirely closed itself. Everything's flushed out of memory. Then I stream it back in. I get the same tree back in. Proof it worked. Marshall.
No, I'm just
Oh, he's resting the cast.
sorry.
Yeah, and this node, notice, is not deriving from serializable. However, we did dynamically recreate objects because this was a shared pointer of a type that it knew was node. So when it knew that it needed to make a new shared pointer, it made a shared pointer of that type and then constructed a node and stuffed it in it after throwing it through the map of my all my pointers. This is a multi-level inheritance where I have the data in the derived type and the generic left-right tree in the base type. So that way the derived type, it could have another one that had names or strings or whatever. And I just reuse the mechanism. But I chain them together through the serializable, CRTB and base. Go to serialize it out, serialize the base first, which saves out the left and right. And here it actually serializes the base, even though there is no base above it. But in case anybody ever injected one above it, it's easily less mechanics to have to rewire. So when I go to serialize this out, I'm pointing at the base pointer of the tree. 1 second, Marshall. And it knows to use the serializable mechanism to recreate the derived object, stuffed it into the shared pointer here, which is actually a shared pointer of type node 1, not the derived type. Marshall, you were about to ask.
Yeah, I was about to ask. In the node 2 class, right?
Mm-hmm.
You have using base equals serializable. And you call base serializer. Fine. Okay. In the top class, you have no type, no using for base, and yet you're calling base serializable. What class is that?
That's slideware that it got left out.
Okay.
It is actually base serialized as actually referring to the CRTP serializable, which since it doesn't have it serialized, it ended up further inheriting from serializable base, which does have an empty implementation of serialize.
I was just looking at that base whole.
Yeah, you'd make a good compiler.
You'd be amazed how many errors the compiler in my head makes.
Yeah. So when I constructed the tree, it looks very much like the previous one, but it was constructed in the multi-layer. I stream it out, I stream it back in. It's accurate. Okay, here's using a socket. In multi-threads, one thread has the client, one thread has the server. And so here's the server side, here's the client side. And what these guys do is they play ping pong back and forth with messages. The very first one starts out and it creates a root node in this tree pointer, and it goes and sends it, it prints it out, or it prints a symbol for, so on the UI we can see streaming server, streams the tree out, I null it out so it erases it from memory. Down here, he starts with a null pointer. The client console output shows that I'm streaming it into the client. I stream in the tree. I add another random node. I call it a client, I give it a random ID. It inserts itself into the tree that was just read across. I stream it back out, or say the client's writing out and streams it back out. At this point, this guy he had sent the stuff out. He's waiting for data to come back. He reads it in. He inserts a server node, a random ID. And this whole thing repeats 5 times. So in my output, I say client server, synchronous reversible two-way start, server starting, client starting, and then you can see clients waiting to stream in, server streams out, server streams in, client, or server's waiting for the client streams out, and this goes back and forth, they play ping pong. And since these were all random of what the values were and they get inserted in the tree, every time you'd run this output tree would be different. And this is what happens after 5 nodes of pinging back and forth. We originally had the root. The client randomly added a node, which was either 0 or 9. I have no idea which one was which. But it plays ping pong back and forth, and they basically add themselves back and forth messages to each other in the tree. And that's just to show that it's busy doing stuff. Once it gets done with the 5 times, both sides shut down and everything joins back together. And I tell that there's a archive done. More questions?
Another question.
Yes, okay, back there.
So where is this being used, or how are people getting their hands on it?
On the cover slide, I did have a GitHub link. I have not pushed it up there yet. I have multiple copies of them. This is not a regular commercial library that I'm pushing. People are free to use any piece of it that they want to, and I'll push it up to that GitHub address that I...
Do you know of anyone who's using it in any kind of hardcore way?
Not that I know of. I've given this presentation before local users groups, and there were GitHubs that were pushed up there for them. This has been enhanced a little bit since then. And there's copies of the video for that out on YouTube. That's the one thing that GitHub doesn't record who stole copies of your stuff.
As well, so.
Yeah.
I have some reservations there too on the series. But so
We were complementary solutions each other. Mine is homebrew hacker. His has to be actually much more stable for production environments.
but what I've seen today with yours is that it is like it looks like it would work, but it seems to be pretty intricate, and the user would have to, have deep knowledge of how your system works.
Well,
And they have a lot of chance to go wrong.
in theory, let me...
In the migrate on the blackboard here, could someone forget to put in the base and just put in serializable migrate and it would work? Or
It-
just
Well,
leave
I mean,
It would-
code would otherwise break because it won't be inherited from my base anymore.
Actually, I have a slide that is basically... I'm going backwards too far. I'm showing you the inside guts of this. People would not typically need to know that. The only thing that they need to know to do this is to, in a multi-layer inheritance, is each class has to have its own serialize, and each class has to derive from the CRTP serializable. Yes,
Right through the CRT.
right. The only point of fragility is if they forgot to put my base here. And at which point, if they serialized out something that was my base, they would only end up with this my base. Or if they serialized my derived, they would only end up with this. That's just a classic inheritance faux pas that people make. But this, for the user perspective, those are the only 2 things in each class you have to have, is the base and the serialized function. The base and the serialized function.
You said you don't even need the base. You can just have serialized function.
If it depends on if you're going to dynamically create it or not, and if you're going to be dynamically trying to recreate, traverse the structure from a base pointer. If you're only ever going to be using a single level nesting or no derived types, and you're always pointing at the final type, you don't have to use a serializable base on that. Just have a serialized function. Because there was a couple other questions. And for the video, Federer was asking the same, but you said you didn't have to use the serializable. And depending on your type of data and if it's nested and if what part of the data you're pointing at, you don't have to. But if you want it to be able to dynamically recreate, you do. Okay, we got just a couple minutes left. Ben.
The latest Microsoft compiler supports deducing this. Have you thought about refactoring the CRTP using deducing this? It'd be interesting to see.
I know that's your baby. Ben was asking about if we can switch over to using deducing this, and we might, but, and I would have to see if, because I have to have the layers between there that have the create functions in there and the type ID for hash. So once it has the hash ID, it can look up the create function so it can dynamically create the derived object.
So what you're saying is that even using these, you need to know the base.
I could figure out the base, but between this, my derived, and my base, there's a serializable, there's an instance of a CRTP template class there, and there's also an instance of the serializable CRTP above my base, because this shows 2 classes. This is effectively 4 classes in the chain. So there's some possibility that this could be used for some of the mechanism. I don't think all of it, though. Okay, 1 minute left. More questions?
Are you taking the final question?
Yes, if you have one.
So again, this is the motivation I late, but I have kind of some opinions about what should be serializable. And I'm of the opinion that pointers, even shared pointers, or even unique pointers shouldn't be serializable. Because it really depends on the semantics of your class.
Well, it's the class one. Okay, the question is, or the point was, or the opinion, that pointers should not be serialized. And yes, but the class knows how to use those. The class knows when it's serializing out what it needs to save and what it doesn't. I'm not serializing out the pointer. I'm serializing out what the pointer is pointing at, and then I reconstruct that. Yes?
But isn't that an optimization that you want to do so you can store archives with share data and work on that way? You're basically trying to realize things that have a lot of shared state.
Well, there's a data structure that I showed at the very beginning that my system I can serialize that out.
Yeah.
But, and so it maintains the relationship to it. If you start at one of these nodes here, that one or this one, it will traverse the whole thing, block from going recursive in looping, save that out, and then I can turn around and reload that later. So the pointers are maintaining the relationships between the objects. Marshall.
I think I misunderstood what you said, because you spoke of serializing shared pointers as an optimization to save space in the archive, and I disagree. It is in fact necessary to preserve the relationships. Yeah.
Otherwise you will be changing.
Otherwise, you're going to have 2 shared pointers, now 2 copies of the same data.
As Simplification says, I mean, this is kind of an incidental structure, right? This is your value, the whole thing. And if you know about the whole thing, you're in the class, then you can reproduce the same.
But it could be entirely dynamic, and
Yes.
and actually all the way at the end, I think I actually had one more example of a circular reference map or data structure that basically it's a star configuration. Nope, I end up not including it. But say I have a data structure that just has a collection of smart pointers. And I can have an object have a relationship with n number of other objects, and each of those has a vector array of smart pointers that can have relationship to any number, and then the relationship runtime can dynamically change, and you serialize out a snapshot of that. You load it back in, you change those relationships, you break some. That picture that I showed of that network, if that were an absolutely fixed hierarchy, you might want to have a parent manager serialize that out, and knowing the relationship and rewiring that. But if it's an entirely dynamic, you have no schema. This whole thing does not save a schema. A lot of other serializations require a schema to know how the data is coming in and out. This is just live pure data. We are 2 minutes over. Thank you very much.